Hello everybody, this is Neha Sarangmat from I Division. Today I am going to explain you the gausse sidel method. This is a numerical iteration method that gives approximate solution. This method cannot be applied to all the equations. The method is applicable when a large numerical coefficient are along with the leading diagonal of a coefficient matrix. Such a system is called diagonal dominant system. Sometimes we need to rearrange the system of documents to meet the condition. Satisfy the solution as the iteration will conserve. Let's look into an example. The given two equations are 10x plus y plus z is equal to 12. X plus 10y plus z is equal to 12. So from the first equation, the z is equal to 1 by 10 bracket 12 minus y minus z bracket close. Y is equal to 1 by 10 bracket 12 minus x minus z, and z is equal to 1 by 10 12 minus z minus y. Let these be equation number 1 2 3. By the first iteration we get it x is equal to y is equal to z is equal to 0. Then x becomes 1 by 10. So as we have taken x and y are is equal to 0, then replace those values, we get the value of x as 1.2. Then take the value of y, then replace the value of x as 1.2, we get the value of y as 1.0x. Then the value of z is 1 by 10 bracket 12 minus 1.2, which is the value of x we got in the above step, and the value of y is 1.08. Then the value of z becomes 0.972. This is the end of first iteration. Let's look into the second one. We are going to replace the value of x y z that we got in the first step in this second step. Then we get x is equal to 0.9948 and y is equal to 1.0033 and z is equal to 1.0018. And we will replace the value of second iteration x y z in the value of third one. Then we get x is equal to 0.99652 and y is equal to 1.0003 and z is equal to 1.00033. So these values of x y z are very nearest and approximately equal to the 1. So we got the values as x is equal to 1, y is equal to 1 and z is equal to 1. As we know, these are approximate value and this method helps in finding the approximation values, not the definite ones. Let's look into the another example. The equation here are given 3. We get x plus y plus 54 z is equal to 110 and 27x plus 6y minus z is equal to 85. 6x plus 15y plus 2z is equal to 72. So we get the value of x is equal to 1 by 27 bracket 85 minus 6y plus z. Let this be a equation 1. And y is equal to 1 by 15 bracket 72 minus 6z minus 22 z bracket close. That is be an equation number 2. And z is equal to 1 by 54 bracket 110 minus x minus y. Let this be an equation number 3. So we will take the first iteration where x is equal to y is equal to 0. We get x is equal to 3.148, y is equal to 3.5408 and z is equal to 1.931. And the second iteration we need to put the value of where the value of x is there, we're going to put the value of y and z that we got in the first iteration. We get 2.4321, y is equal to 3.628 and z is equal to 1.927. When we got these values, we were going to put these values in the third iteration. In the third iteration, we get the value of x as 2.4256, y is equal to 3.5729, and z is equal to 1.9259. We will put these values of x, y, z which we got in third iteration in the equations we get in the fourth iteration. We get x is equal to 2.4 and y is equal to 3.5 and z is equal to 1.925. As we got the values in the third iteration and the fourth iteration, the values are same and nearest to each other. We will going to end this process here itself. Thank you for watching my video.